Okay, all right. As I was saying a few minutes ago, if you just do a search on Dev C, if you did Dev C++, it would give you the same thing right there. But the there's multiple places you can download it from. I typically download everything from source for simply because I know that that's a secure site. Now, this particular version of the software, I should point out, is what they call GNU, which is basically it's free integrated software. I mean, it's developed by a conglomerate of users, and there is no charge for it. If anybody wants to charge you for it, you're at the wrong place. This is completely 100% free. It's just like Linux and a lot of the other that they're. I usually avoid downloading from places like Hupo and Orville, Blogspot. That there, um, Bloodshed. That there. That's okay because they're actually the organization that does the that there. But I don't remember all the organizations, so it's usually SourceForge is usually where I download from right there. And actually, I guess brought to you by Orville Dev C++. So I guess Orville is right there. And this kind of explains everything about it, what it is that they're. It's a Premier, and that's other business right there. But basically, what it really is it's a C file. If you hit the download button right there, you'll get choices of versions to download. But evidently, this one doesn't give you. It picks up on the fact that I'm running Windows 10, so it downloads the right version from Windows 10. Right there. You keep it right there. And when you go to install it, it's going to take 2 minutes right there. I'm going to probably stop the installation since it's already installed. But it's going to say version 5.11, but the actual version of the compiler is 4.92 right there. So now you may run in the first time you run this, you may run into some funky errors that in terms of whether you're running the debug or the release version right there. So I'm going to just go ahead and let that download in the background and just kind of bring up the software. It installs pretty much like any other software right there. Everybody in this room's over the age of 12 and under the age of 30, so you know how to install software on PCs right there. In my more recent years of teaching, I've discovered that it's the older students that have more trouble than the younger students figuring out how to install software. That's there. Just like using a modern TV remote. My 4-year-old niece will come over and show my wife how to use the remote control. So, okay, once the software is installed, right there, it's going to go into a directory called Bloodshed. That's why I thought it was Bloodshed. Right there. If he comes to that door, just let him in. That's there. And it's Dev C++ right there. And it's going to look just like this right here. And I'm not doing this off of a script, so I could very well make some mistakes. It's not the first time that's there. But when you first run it, it's going to look like this. Now over here, this is where I'm saying you may have to try. There's multiple versions right there. Depending on what version of Windows is installed on your computer. I've got the 64-bit version, so I do the 64-bit release or the 64-bit debug. The profiling you would not use. I've never used that version. If you've got a 32-bit operating system, which I'm thinking these might be, you have to use the 32-bit. either release or debug right there. I have not had much luck with the debug with the software that's there, but so I just use the release. And what we're going to do is I'm just going to kind of go through the steps. You're free to go ahead and turn on your computers and follow along. I'll go slow enough if you want to follow me that's there. But once you bring the software up, you're going to create a new file, new source file or project. It's about as easy to just go ahead and create a project right there. And we're going to create a console project. And that's important that we do a console project for our programs that we're using right there. And I'm going to stop this that there. You know, well, I'll go through it to first start just so you can see that it's, but it'll give me an error because I've got the program running. So right there, it unpacks and it installs just like every other version. Right there, unpacking data. Select a language. I agree. See that there. That there, and then you just go through and I'm just going to go ahead and cancel at this point, just simply that there. So I'm just going to go ahead and this is a C project, not a C++. C++ is a different syntax, and if you do what I'm doing in this class and follow the examples from the textbook in this class and the slides, you'll get all kinds of errors. So don't say please C++. And I'm just going to call this project 1, and I'm just going to call this computer mat P1 just for sake of it. Now I just go ahead and make that the default language at this point right there. You know, it still will come up and ask you that, but it'll default to that. Okay, right there. And now it's going to ask me where I want to put it right there. And I'm going to create a new directory under C programming. Right there, and just put it there. So when you do this, it brings up a shell program that all it basically does is it defines a function called main right there. Everything in C, and we'll talk about this later, is done in functions. You know, so we haven't really looked at doing the C syntax yet or anything right there. We haven't covered any C, but this is this right here is, these are two library calls. Standard IO is one of the libraries that allows me to use things like scanf and printf in order to get things in. And standard library is just the standard C library right there. And those two lines just need to be at the top of every program you write. Otherwise, the C compiler won't be able to find all the standard library functions. This line right here is int, is what main is going to return an integer right there. Main is a function and it returns an integer. In this particular case of this particular program, we don't really care what it returns. Now int here and argument char, this simply is something that we can pass arguments to main if we want to. So for example, if we're running this program from what they call a DOS window right there. And when you know, nobody in this room is old enough to remember DOS, the disk operating system. I grew up with DOS. My first IBM PC came with DOS 1.1. right there. You know, that was a very old computer back in 1983, I think it was. I bought my first, and that was an original IBM PC, you know, the great big one, the 5150 model, right there, which was the original PC. It came with DOS 1.1, and Windows wasn't even heard of yet. And DOS stands for Disk Operating System. It came on floppy disk, so I had to have a floppy disk in the computer when I turned it on. Otherwise, it came up in what they call ROM Basic, a very simple language. I could write basic programs. I couldn't save or anything with it. So, but DOS 1.0 was actually an operating system that was a version derived from something called CPM, which was the computer programming for microcomputers, which was an 8080 C80 operating system that controlled digital, digital research came up with DR, because they also came up with something called Dr. DOS. It wouldn't work on the original IBM PC, so some goofball by the name of Bill Gates figured out a way to make an operating system work on the original IBM PC. He sold it to IBM. He actually didn't sell it to IBM. He licensed it to IBM. He kept the rights to it. It's probably the smartest business move made of any individual in the last 100 years, because you know, IBM is a company you almost never hear of anymore, but Microsoft is definitely a big player, which was Bill Gates' company. But DOS operating systems, that there is also referred to as a console window, right there. And we used to write DOS commands, which would be like disk copy a : where we would pass arguments to DOS programs. So this here allows us to pass arguments to that there. I could actually delete this whole thing right here inside here. Right there. And it'll work perfectly fine. And I could actually put in here, which would be the more correct, the word void, which means that I'm not going to pass any arguments into it. Normally, when you write programs, you would put the word void in there because you're not going to be passing anything to it. So now I'm going to basically write the simplest program I can write. And this is the standard Hello World program, just simply to see whether it works. And the command for writing a program for printing in C is printf, and then hello world, right there, and then /n for new line. So if I did everything right, this should print the word, the phrase that there. So once we're done with that, we would hit project or execute. We would compile this, and I'm just going to call this, and I probably ought to just call it the same as that there. This was C math, right there. I want to take the .dev right there out, right there. And it's a type C program right there. So I hit save. And for whatever reason, my phone is right there. So it compiled cleanly. Oh, yeah, out there. Expected before return. Oh, I forgot the semicolon. Right there. Every executable line in C has to end with a semicolon. So I forgot the semicolon. So we hit the execute, compile it again. Now, note that when I do this, I get this little window on the bottom right there. This is building make file, blah, 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 blah. And then runs a program called GCC where it passes a whole bunch of that. GCC is the Linux compiler right there. So when you install dev C, you're actually installing a program as part of it called GCC, which is the Linux-based C compiler right there. Anything that comes from SourceForge is actually part of that Linux group right there. And if you remember my lecture from last week, and I know some of you have slept then and completely forgot everything that's there, but I mentioned that Unix was written in C, and a lot of the Unix world still lives with C as the primary programming language. Linux is a version of Unix right there. So whenever you're dealing with dev C, you're going to see some of the remnants of the Linux world that's there. I personally like Linux as an operating system over Windows. I used it for years as my primary operating system and not Windows. It has some huge advantages. The number one advantage that Unix has over Windows is every time it does an update, you don't have to reboot. It doesn't reboot on its own. It's a much more stable operating system right there. You don't have the error or the virus problems and that there. It's got one huge problem that I would probably go back to Linux, but because I'm teaching this class, the second half of this class, I'm going to have to teach MATLAB. And there's not a version of, actually there is, and we'll talk about this later when we get into MATLAB. There's actually a version of MATLAB that is free for Linux. And it's also free for Windows. It's called, just drew a blank here, Octave, right there. And Octave is what I'll probably be using when I'm teaching MATLAB, because you can download that onto your laptops and it's free, right there. So, but Octave is built into Linux. So actually, MATLAB as we know it, that there is actually a commercial product that's extremely expensive, but it's actually a copycat of a free product that's available under Linux. That there is also available, but the toolboxes aren't available for that there. But get back there. Once we've done this, then we go to execute, and we can just simply tell it to run right there. And as you can see, it prints hello world. That's the simplest program you're going to write right there. And this is really the whole goal of today and this whole week. I just simply said was for you to simply repeat this process. That's there. So let me just go through it again briefly. I'm going to just start right there. Now what will happen if I hit this and say 32-bit release, and I do execute, and I do compile and run. In this particular case, it ran because a 64-bit operating system will run the 32-bit. But if these are 32-bit operating systems, you'll have to make sure that they're, I'm thinking, if I do the debug, will it work? Project, rebuild all. Now mine is working with all versions, but I had trouble last semester with different people having different problems. If you have trouble at there, try the 32-bit release, try the 32-bit debug. At there, the profiling, I'm not sure. I've never tried that, but we'll try the execute. Yeah, everything's working with with this version of Windows, but we had trouble with the other lab over there that only one of the 6 versions would work right there. So we had to experiment a little bit to get one of them to work. but for whatever reason, mine are all working. Also notice where it says return value 0. If I go back to this right here, if I change that return to 999, and you don't have to compile, you can do a compile and run. You'll notice it says return value 999 now. Again, it doesn't do anything, it just prints it on the screen right there. Now, that becomes a little different when you're writing batch files, and a batch file is a program that runs under DOS that will call executable programs and look at the return value and do different things right there. So, but for right now, this process took 1.25 seconds, which is a long time, but execute, if I tell it to run, notice it takes less than 500ths of it. It takes right about 500ths of a second. It was the compiling that took a second and a half right there. And this should be a fairly fast computer up there. It's an i7 with 16 gig of RAM, so it should be fairly quick. But go ahead and follow the steps that I just did, and just make sure that you can run a program starting next week, because we won't meet tomorrow. Tomorrow's Taipusan, right? Everyone agreed on that one, right? That's there. So starting next week, I'll probably lecture for a while and then give you a program to write after the lecture. So, but for right now, I'm just going to kind of turn it loose to you for the next how long it takes you to write a short little program. And you don't have to turn anything in. Once you have it working and you're convinced, can someone see it? Is Dev C installed on these computers? What? Oh, okay. Go ahead and someone open the computer and tell me whether Dev C is there. Hopefully we don't have to install it. It's supposed to be installed on all these computers. I don't know where my student is that wanted me to sign this, because it is on there? Okay. So just basically just go ahead and create, again, I'm going to just close it and bring it back up and create a new project. Right there. I'll just go through the steps again. Right there. The first step is, if it comes up, is that we create a new project, file, new project, console application, right there, C project, not C++. Okay, I'm going to put it in the same place, that's there, save. It brings this up. Now the only thing you need to do is you can leave that first line alone. I changed it to void. You don't have to. Just do the printf. Printf. Hello world. \n. If you forget the \n, that's fine. That's there. If you leave the \n out, execute, run and compile. Right there. And project. 1 right there. And I again forgot the semicolon. Right there. Project. Execute. Compile and run. And there's your hello world. And that's your first program is run at this point. Yeah. What? Okay, let me go slow again. All right, let me start over again and let me go very slow. And this is still recording, so you can always go back and watch the recording. All right. Go to Dev C+ right there. open dev-c++. Okay? Once you've opened that, this is where things get a little bit tricky. You should have a screen that looks like this. Then you go to File, then New, and then you do Project, right there. And once you have Project, you hit Console Application. That's the first decision you have to make, is you have to decide. Now, Windows application means that it's going to give you, a Windows form to fill out, and that there. We're not going to do that this semester. We're going to just stick to simple Win applications. That there. A static library means that we're going to create a library. We're not going to do that. A DLLL is a dynamic link library. That's a Windows library. We're not going to get to that point. And an empty project means that we do everything from scratch on our own. So if you pick the console application, it gives us that shell right there. So I'm just going to leave it project 1, C project, not C++. You can give this any name you want. You can check the make default language, or you can not check it, doesn't matter. You hit OK. And now it's going to project 1 right there, and I'm going to just hit save, and I'm going to just replace the old one. Now this is that empty shell. This is just an empty shell. Now, in this empty shell, and I'm just going to repeat this, just simply that the first 2 lines we will use for each and every program we write. We'll be adding additional lines to this down the road, but right now those 2 lines just need to be there. This particular one right here is this first line is a comment. Run this program using the console pauser or your own C-clutch or system pause or input loop. If you run this a certain way, it just flashes up and disappears, and I'll show you that in a minute. But this is our program right here. So our program consists of, right now, 1 line, return 0. There's nothing else in there. So if I run this program, execute, compile and execute right there. And I'm just going to rewrite the old one, save right over it. It doesn't do anything right there. So to see that works, we're going to go ahead and we're just going to put a print statement in there saying hello world. And that goes after this opening bracket. There's a bracket here and an end bracket there. Everything in between that is our program. So I'm just going to do.
So we need to write in between that.
In between those, yeah. Just before before return 0. If you write it after return 0, you won't, because return causes the program to exit. So I'm just going to do the word printf right there, and print is a keyword to tell it to print, and F is formatted output. So printf, we put it in parentheses because printf happens to be a function that we're calling. And we put in quotes, make sure right there, we put in quotes, hello world. Now we can put anything we want, and then I put a \n there in order for a carriage return. Now I could put more in there. Hello world, isn't this fun? Right there. And then we'll print two lines there. So, right there. So once I've done that, Now don't forget, like I've been doing, and put the semicolon at the end of the line. Right there. So printf hello world /n. If you leave the /n out, that's fine. I'll just print it all on one line. Right there. And that's a quote there at the end. Yeah. Yeah. Double quote right there. It looks like it looks like I have a typo here. It looks like I accidentally hit the single quote there. It should just be a single one double quote right there. And then we just go to execute, and you can just hit compile and run at this point right there. And that's it. You know, it's run that there. Now, if I put a line after the return 0, right there. If it's after the return 0, it won't work.
So before hello, we should put the double quote.
Yeah. As soon as you put the double quote, it'll actually put the closing one in for you. As soon as you put in the first one, the second one shows up, and you just type in between them. So if I run this again, warning, missing terminator.
Or you're missing end of the extension.
Oh, there we go. Oh. Right there. Okay. Sometimes you guys see that quicker than I do. And notice that it didn't show the one after the return. But if I go up here and I put a // in front of that to comment that out, then it shows up. Incidentally, that return is optional as well. As it turns out, if you leave the return off, it still works. Right there. So the return is also, just as I said, everything in here is optional. Right here.
So to run that, execute.
Yeah, execute and compile and run. Yeah. And as long as you didn't have any typing mistakes, it should run. Yeah, last week I think, did we only have 6 people that show up for class?
Yes.
Yeah, it's a little bit more today.
So print F should be capital letter or no?
No capitals.
Okay.
Yeah, and C is particular about if you put a capital letter in, it will give you an error. So in other words, if I did print F right there like this,
Wait, what does that mean?
it gives me really nasty error too. See, I'll never find this error. But yeah, the error is really nasty. So yeah, make sure it's all lowercase. Yeah, I was going to show that. Yeah, you know, on that top where it says print main and it's got the opening and closing brackets, if you just left those empty, it'll still work. And if you took out the return 0, it still works. Right there. Right there. So it doesn't need that return 0 is not needed. And everything in that parentheses behind after main, that's not needed either. Right there. So this is actually probably the simplest program you can have there. You can't get any simpler than this right there. Right there. And of course, they'll get more complicated as time goes on. What's that? Yeah, only the first. Yeah, you only need the one line. The printf is all you need right there. And as soon as I hit the F11 key, F11, see it runs right there. I don't know why it's giving me that error there. It's wanting to reload the make file. Now, there's a lot of things happening in the background that we're not talking about, and that's okay. I'm going to go ahead and stop my recording here at this point.